We are inside the cryptography basics room and we are at task number 4, historical ciphers. Cryptography's history is long and dates back to ancient Egypt in 1900 before Common Era. However, one of the simplest historical cipher is the Caesar cipher from the 1st century before Common Era. The idea is simple: shift each letter by a certain number of encrypted to encrypt the message. Yeah, so basically if we choose the letter A, encrypting with this cipher at Caesar cipher, A will result in D. Very simple. Consider the following example. So our plain text is this. This is our plain text key 3. So shift try hack me with 3, right? Every letter in try hack me, shift it 3 times. The cipher is Caesar cipher, right? The algorithm that we want is Caesar cipher. We can easily figure out that T becomes W, R becomes U, Y becomes B, and so on. And you noticed once we reach Z, we start all over. As shown in the figure below, consequently, we get this cipher. So this is encrypted data with this cipher, Caesar cipher, and is try hack me, basically in plain text. This is encrypted data with the Caesar cipher. To decrypt, we need the following instructions. We have the ciphertext, we have the key number 3, and then we need our algorithm, which is Caesar. For encryption, we shift to the right by 3. For decryption, we shift to the left by 3 and recover the original plain text, as illustrated in the image below. However, if someone gives you a ciphertext and tells you that it has encrypted using Caesar cipher, recovering the original data would be a trivial task, as there are only 25 possible keys. The English alphabet is 26 letters, and shifting by 26 will keep the letter unchanged. Hence, 25 valid keys for encryption with Caesar cipher. The figure below shows how decryption will succeed by attempting all the possible keys. In this case, we recovered the original message with key number 5. Consequently, by today's standards, where the cipher is publicly known, Caesar cipher is considered very insecure, obviously. Here is the encrypted text. And at key number 6, this is Alpha Bravo contacting Tango Hotel Mike, right? We try every key to decrypt this text, and we get it by 5. So it's just an algorithm here that used all the letters in the alphabet and just try to shift to the left because we decrypted. And then shifting by 5 basically succeeded with the message in clear text. You would come across many more historical ciphers in movies and cryptography books. Examples include the Vigenère cipher from the 16th century, the Enigma machine from the World War II, the one-time pad from the Cold War. You can experiment with Caesar cipher shifts using the interactive tool at the Crypty website. It lets you tweak the rotation and instantly see how the text transforms. Answer the questions below. Knowing that the following was encrypted using Caesar cipher, what is the original plain text? Okay, let's copy this encrypted data. And here we have our recommended website. And we can play with this. Let's decode. Here is this. Shift by 3. Plain text. So it's not 3. It's not 2. Let's see. Oh, I see it. I can encrypt. So it's 15. The key is 15. Cool.